This video will cover topics related to firms that sell their product in a purely competitive market. There are no real-world examples of purely competitive markets, but the industry that comes closest is agriculture, markets like the corn market or Brussels sprout market, etc. Here are characteristics of a purely competitive market. The main focus of this video is to determine what output a seller should make. In this decision, like all decisions, economists say you should follow the golden rule, operate where MC equals MB. Remember the tattoo I'm going to get to really sear this concept into students' minds? This is a vision that they will never forget, even if they want to. So, marginal cost equals marginal benefit is the golden rule, but for sellers, their marginal benefit is the marginal revenue they will get from making the next unit. They want to compare this to the cost of making that next unit. If the marginal cost is less than the marginal revenue, then they should keep making more output until marginal cost is equal to marginal revenue. We already know a seller's marginal cost from the basic short-run cost curves graph. For the marginal revenue part of the equation, we first need to talk about the demand curve for the individual seller in a purely competitive market. This graph shows the market demand and supply for the industry. That supply curve is a list of all the quantities supplied by all the sellers at each possible price. And the demand curve here is showing the total amount of the product that all the buyers want to buy at each possible price. You know from before that where they intersect determines the market price of the product. Let's say that this is for corn and the market price for each ear of corn comes out to $1 per ear. The characteristics of a purely competitive market are that there are lots and lots of sellers that sell an undifferentiated product. This means that one farmer's corn is no different than any other farmer's corn. There is no non-price competition because no farmer can say their corn is better than the other farmer's corn. If you've ever been to a farmer's market, you'll notice that all the sellers of a similar product charge the same price. If one seller thought to charge even 1 cent more for their corn, no customer would buy it. However, because each farmer is such a small provider of total market supply, they can sell all they bring to market if they charge the market price. The resulting demand curve for the individual seller looks like this. It shows that when the seller charges market price, like $1 in this case, they can sell any quantity they can produce as a small provider. If they brought 3 ears of corn to market, they can sell all 3 if they charge $1. If they brought 50 ears of corn to market, then same thing. As long as they charge $1, they can sell all of them. But if they charge even 1 cent more, they will sell none. Now, they could sell any amount of corn they can make for less than $1 per ear, but that would be pretty stupid since it would only lower their total revenue. Economics assumes rational behavior, so the only choice a seller has is to charge $1. Now that we have the concept of an individual seller's demand curve down, we can start to talk about the marginal revenue part of the equation. So what is marginal revenue? Marginal revenue is change in total revenue. So we'll add a total revenue column here. Do you remember what the equation is for total revenue? Remember, if I sell 12 cupcakes for $1 a piece, then my total revenue is $12. How did I compute that? I took the price per cupcake and multiplied by the quantity of cupcakes sold. So, total revenue is price times quantity. The demand curve for the purely competitive seller says that the price is constant. I can fill the price column with a $1 figure because $1 is the only possible price. Then I can put in the various possible quantities. Knowing the total revenue is price times quantity, go ahead and fill out the total revenue column. Pause the video if you need. And now that you have the total revenue column, you can fill out the marginal revenue column. I did marginal revenue for the first unit. It is $1 because in going from 0 to 1 unit, total revenue went from $0 to $1. So the change in total revenue was $1. Now you fill out the rest of the marginal revenue column. Pause the video if you need. What do you see as the relationship between price and marginal revenue? Why, yes, you should see that price and marginal revenue are equal, because each time another unit is sold, it sells for $1. The change to total revenue with each additional unit will be $1, the price of the product basically. If we graph the marginal revenue curve, we would see that at 1 unit, the marginal revenue is $1, and at 2 units, the marginal revenue is $1, and at 3 units, marginal revenue is $1. And graphing this, we would find that the marginal revenue curve would lie right on top of the demand curve, and we can basically say that the demand curve is equal to the marginal revenue curve. So now that we know how to compute and graph marginal revenue for a purely competitive seller, we can now move on to finding that magic MC equals MR point. But before we do, just one more point. We could add a column to the table here to compute AR for a purely competitive seller as well. The definition of average revenue is total revenue divided by total product, or the quantity. If I do the computations for average revenue for the third unit, I would get $3 of total revenue divided by 3 units of total product, and that would give an average revenue of $1. Go ahead and fill out the rest of the AR column. Pause the video if needed. You should have found that AR is also $1 all the way down the table. If we plotted this information on the graph, we would find that the AR curve also coincides with the demand curve. Some very clever econ teacher at a conference said they teach their kids to remember the concept that price equals demand equals marginal revenue equals average revenue by remembering Mr. DARP. Mr. D-A-R-P. Okay, so now we are ready to find that magic point where MC equals MR.